Good morning, everybody. We're looking at a relatively famous number. It's a Fermat number, and they're defined like this: 2 raised to the 2 to the 6th. And so this would be the 6th Fermat number. And a guy named Landry, a mathematician, a French mathematician, last name Landry, not Tom, discovered or figured it out with pre-technology back in 1880. Back in 1880, this guy Landry, French-sounding first name, last name Landry, discovered that this is composite. The first 4 are actually prime, okay, but they believe that the rest of them are composite. Now, semi-prime just means the product of 2 distinct primes. I believe that distinct is important. I don't think you would consider p squared semi-prime. I'm not sure, though. It's not particularly important. But we know one of the factors. That's a given here. Okay, this is the first prime divisor. And now we want to find the last 2 digits of the second prime divisor. Now, you know how this is a huge number. I believe it's in the range of 20, 21 digits. So P is a much larger prime than 274,177, 274,177, okay? We want to find the last 2 digits, okay? Now, y'all, just an example of what we're doing here, like, say we have 189, okay? That's congruent to 89 mod 100. That is, when you divide it by 100, you get a remainder of 89, and so you write mod. It's modulo. We just abbreviate it. Modulo 100. So that's what we'll be doing right here. We'll be analyzing this expression 2 different ways, mod 100. Now, this first one's very, very easy, right? 274 or 177 is congruent to 77, so we can replace it. Modular arithmetic turns division into equality, basically, divisibility into equality. It's a way to make divisibility look like equality. It's very powerful, okay? So this very first statement is very easy, okay? Now we're going to find this mod 100 another way, okay? And then we'll equate the 2 ideas, the 2 results, okay? So this part was easy, okay? Now this doesn't take too much time. 2 to the 9th is 512, which is congruent to 12. And notice this reduces the computations immensely. So again, we're trying to re-express this in a way where we can equate this with whatever we get down here. Now, a lot of this probably I don't need to explain too much. Laws of exponents right here. 9 times 6 is 54 plus 10 is 64. So this, notice here, this is just equality here, okay? Now we get the congruence because we know that 2 to the 9th is the same as 12. You see how the 12 appears right here, folks? Okay. And of course, I just wrote down 12 because, and this will help a little bit right here. 2 to the 10th is 2 to the 9th. 2 to the 9th times 2, right? So you see that's how this 12 appeared here. Okay? Now the rest of this, I don't know how much I should say. Computation here, 12 squared. I'll just write it right here. 12 squared is congruent to 44. And it's understood that we're talking mod 100, okay? That's 12 squared, ladies and gentlemen. 12 squared is congruent to 44. I'm not leaving much space here. But that's where this 44, you see, because 12, it would be squared cubed is to the 6th power, right? So that's how we got 44 to the cubed right here, folks. Okay? Hopefully this is enough notes to make sense. And then the rest of it's just computation. Let's see here. I really probably should just have put an equality right here. Maybe, I don't know. Equality would work, but congruent, if 2 things are equal, they're also congruent. But the 1936 is just a calculation right here. Okay, just a calculation, an arithmetic calculation. Then right here, it's a true congruence. See, 1936 is congruent to 36, and you see how we're gradually reducing things. Okay, now I'll move along. There's not a whole lot of big calculations right here. What I did right here is it's fairly easy to do. 36 times 24 gives you 864, right? And so 864 reduces to 64 and so on. And probably the biggest hand calculation was knowing what 64 times 44 plus 1 is. That's down here on the very next line. That's 2817. So what we get is 2817 is congruent to 17. Now you see, y'all remember, we're equating this object with whatever our result is right here. So that's exactly why I wrote this down. Now this is kind of tough right here. If you're not familiar with, this is tough to check this one. We're trying to find the last two digits. We're trying to get P isolated. But observe, and this is a tough find. If it was much larger number, it would have been hard to find. But 77 times 13 is 1001. Well, I shouldn't put it. It's not congruent. You can write congruence, but it's a little dubious to write it. But that's congruent to 1, right? It'd be better to write equals and then congruent to 1. This is technically correct, but it's dubious in a manner of speaking. So you see, what that means, if you multiply through by 13, you'll get 13 times this 17 is 221, right? And then 77 times 13 is just 1 on this other side, okay? And just for emphasis, I'll write down 1p. Right? But notice mod 100, this is just congruent to 21. Again, here the 1 was just put for emphasis to know that we're doing something actually. But tremendous amount of reduction in magnitude just by using modular arithmetic. So again, this is mod 100. And that's our answer. And what is our answer? Our answer is the that's 21, folks. I'll write 21 underneath there just to be safe for you. But the last two digits of P, okay? The last two digits of P is 21. Okay. Hope you liked it. I thought it was kind of cool. I just looked it up in a book. This isn't I created this problem. Leave it for you to decide whether it's worth it. You know, you're cheating in a way because you look up this number, and I knew what this number was, but I wanted to use modular arithmetic just to find the last two digits. And I wouldn't know, outside of just doing long multiplication, there's no way. I mean, what would you do here? I mean, how would you, could you, let me know, guys, if you can do this manually. I don't think there's a way to do it that's not so error prone that there's no way you're going to get it right. I mean, technically, you could divide 274,177 into this number, and that arithmetically in form is what P is. I don't see it. I don't know of a human on earth that can do that manually. You know, somewhere you would have to use a calculator technology, and even if you knew the Hindu Arabic version of this, very few people would get this right. They wouldn't. It's obviously something that will be a prime number. Well, it's, you know, it's known. That's known. But I don't see how you could do it manually, really, by hand without the aid of technology. Anyway, we are done. Thank you for viewing the video.